Okay, let's go ahead and get started. Thank you all for coming today. We've got a lot of screens in these rooms. Some of you have your own screens down there. I hope you're enjoying it down there. Feel free to move into the center, too, if you want. Plenty of seats everywhere. So for those of you who don't know me, my name is Scott Schnall. I'm a principal technical writer on the Exchange team. And among other things, I help build the Exchange product by writing the product documentation and doing user interface strings and event log entries and other things, specifically in the areas of high availability and site resilience and a few others. So I'm really excited to be talking to you today about Exchange 2010 high availability. This will be pretty different from the last session if you were at the design consideration session. That session is focused on all of your design choices, all the things that you need to focus on when you're designing it. This session is focused on how things actually work. What's going on under the covers? What's the replication service doing? What's Active Manager doing? How do we select the best copy and so forth? Now, we do only have an hour. Normally, this is at least a 75-minute presentation, although even then, we could go on and on and on, getting deeper and deeper and deeper. But I think at the end of the hour, you'll have a pretty full head to begin with. So I think it's just as well that this gets capped at an hour and doesn't take it to 75 minutes. But for those of you who are interested in more information, when you do get the soft copy of the deck, all the material that I didn't think would fit into this hour, I put as hidden appendix slides at the end of the deck. So you'll still get all the same content, even though it's a 60-minute session. And hopefully you'll download that and find it useful as well. So we just have a few things we're going to talk about, though. We're going to go pretty deep. We'll do a deep dive on some of the high availability basics. Normally, we'd start out with kind of a primer and level set things. But I'm going to go ahead and assume that everybody knows what a DAG is and what mailbox database copies are and so forth. So we're going to start and get pretty deep on some of the basics like quorum and witness. Then we're going to dive deep on the advanced features, things like Active Manager and best copy selection and data center activation coordination mode, and lots of other big words as well. But we'll make it understandable. Then we're going to end up at the end with some of the high availability improvements that we have in SP1. We won't be able to talk to all of them because of time constraints, but we'll talk about what I think are the highlights and the big wins that we have. Okay, so let's start with the deep dive on the basic stuff. Okay, so we're not going to cover what a DAG is or things like that, but we are going to get pretty deep into the concepts of quorum, the concept of what witness is used for, what a witness server is, and how to handle DAG networks since they're very new to Exchange 2010. Okay, so let's talk about quorum first. Now, hopefully everybody in this room knows what I mean by quorum. Quorum is not a new term. Quorum is not unique to Exchange 2010. Quorum is, in fact, a very old term that Exchange has usurped from Windows failover clustering. And actually, even before we had technology and clustering, the concept of quorum existed. Okay? So quorum is the way that we ensure that only a subset of the servers that are in our DAG or in our cluster are up and functioning. Now, when we say only a subset, that means it could be all of the servers, because the whole is the same as a subset, or it could be a portion of those servers, some of the servers that have quorum that are still able to keep up and running. Servers that don't have quorum, they come down. Servers that do have quorum come up. I think what confuses people most about quorum, though, is that we have this dual usage. We use it to refer both to the notion of quorum, in other words, having a sufficient number of voters available to maintain quorum, but we also use it to represent the physical resource inside the cluster, and in some cases on disk. So we talk about the quorum resource, or the quorum files, the quorum database that are on disk. But we also talk about the concept of quorum, and I think that tends to confuse people, that sort of dual usage. But quorum is a very easy concept to understand, because simply put, when a majority of the members in a solution that's based on quorum are in communication with each other, they're said to have quorum and they continue operating. Those servers that can't reach the majority, they're said to have lost quorum and they shut down. They don't participate in that solution anymore. Now, why is that important? Well, quorum isn't just necessarily there for cluster functions. It's required for DAG functions as well. Okay, so obviously we know from the cluster days, if the cluster doesn't have quorum, that part of it comes down. But we have a DAG on top of the cluster with Exchange 2010, and if the cluster doesn't have quorum, the DAG doesn't have quorum as well. And if the DAG doesn't have quorum, you don't have high availability anymore. Now, Exchange 2010 is only using 2 of the 4 available quorum models. Windows Server 2008 has 4 different models. We only use 2 of them. We use the node majority quorum for those DAGs that have an odd number of members in them, and we use a node and file share majority quorum for those DAGs that have an even number of members in it. And what's beautiful about this solution is several things. First, Exchange is automatically going to adjust the quorum model for you. As you add servers to a DAG, remove servers from a DAG, Exchange will fix up the quorum based on the model that you need. Okay, so you don't have to worry about that. You can add a server, you don't have to touch the cluster tools. You remove a server, you don't have to touch the cluster tools. Exchange will take care of that for you. And it will dynamically and automatically switch between the two as you move from an odd number or even number of DAG members. Now, quorum is important because once you know the number of voters that are required to participate in quorum, you then therefore can deduce the number of votes you can lose and still maintain quorum. And obviously, as you can see from the example, the larger the DAG that I have, the more votes I can lose, the greater the resilience I have. Okay. Now let's talk about the witness and the witness server. Okay. Again, these are not new concepts. They come from the majority node set cluster quorum model. And in fact, in 2007, we had something similar. We just called it the file share witness. We were using the actual cluster name for that. In 2010, we actually did a lot of work. We wanted to hide clustering as much as we could. We didn't want you to have to use the cluster tools. We didn't want you to have to use cluster troubleshooting or monitoring interfaces. We didn't even want you to have to install clustering. We, Exchange, will install it for you when you're ready to add a server to the DAG. So we tried to hide everything as much as we could, and in doing so, we moved away from the cluster parlance of calling it a file share witness, and now we simply call it the witness or the witness server. Okay, so what is the witness server? Well, the witness itself is nothing more than a directory and a share. Okay, and it's a very lightly used file share as well. And it can be a file share on any member or any server in your forest that's not a member of the DAG. Okay, the witness can never be a member of the DAG it's a witness server for. So it's always going to be external to the DAG, but it can be literally any Windows 2003 or Windows 2008 server in your forest. Okay? There's not a lot of requirements for it. Now, because the witness server is not a member of the DAG, it's also not a member of the cluster. Okay? So it doesn't contain a copy of the cluster quorum. It doesn't participate in quorum decisions. There's no cluster database on it. It's just there to add a weighted vote to surviving members in case we need it for quorum decisions. And you'll see what I mean by that in a little bit. Now, so how is the witness represented? Well, if you actually open up the cluster management tools and you look at the default cluster resources, or what we sometimes call the cluster group, that's when you'll see the witness represented by a file share witness resource, a cluster managed resource. Now, that resource, of course, will only exist when the witness server is in use. So if you have a DAG with an odd number of members in it, you're not going to see a witness resource. It's only when you have the even number that the witness resource shows up. Now, the witness resource is only critical when it comes time for quorum decisions. Sure, it's a cluster resource, so it's going to get heartbeated. We'll send the is-alive check and make sure that the resource is up and running. And it's cluster managed, so if it's not up and running, the cluster will try to restart it. If it can't be restarted, it'll be moved over to another node and try to restart then. And if that doesn't restart, it'll just sit fine in a failed state. And in fact, the witness resource and the whole cluster group could sit in a failed state for as long as 30 days. Okay, we don't really need those resources to keep things up and running. Now, after 30 days, it's a different story. After 30 days, Active Directory garbage collection will kick in. The cluster network object, also known as the CNO, could get garbage collected out of the system. And of course, that's the security context for your cluster. So if you lose that, you've lost your cluster effectively. But assuming it's not down for 30 days or more, you're fine. This thing can go up and down as needed. If it is needed for quorum decisions, the system will try and restart it. Oops, didn't mean to hit that. And we actually, that's not unique to Exchange, by the way. We had that documented in that KB because it is relatively new behavior in Windows Server 2008. Okay, in 2003, if the witness resource was needed for quorum and we couldn't restart it, we would leave it in a failed state and not try to restart it. Now the new behavior is to try to restart it once an hour. Okay, so at least we're trying to bring it up. Now, if it turns out that the witness resource is not online, but it's needed for quorum, in other words, we've lost potentially a majority of the voters, and now we need to activate the witness to maintain quorum. So here's where the system's going to try one time to bring it online. Okay, if it can bring it online, that's great. Any node that can be in communication with that server can place a server message block lock file on the witness.log file on that witness server, and that's called the locking node. And the locking node is the one that, when in communication with the other survivors, has quorum and maintains the majority. If it can't be updated, if it can't be restarted, it's considered failed, quorum is lost, and the administrator has to intervene. But as long as the witness can be restarted and used for that locking node when needed, life will be good, quorum will be maintained, you'll get that lock, and when the lock's no longer needed, it'll be released. Okay, now the thing to keep in mind is only one of the members of the DAG is going to be able to lock that file. Okay, and that node, as I said before, we refer to that node as the locking node. So all other DAG members that are in communication with the locking node are considered to be in the majority, will maintain quorum, and will stay up. Any DAG members that are not in communication with the locking node are considered in the minority. They lose quorum and they will go down. And we'll see some examples of that in a little bit. Now, in terms of the witness server itself, this is the server on which you host the witness share and the witness directory. And again, Exchange creates those for you. You don't need to worry about that. Typically, the only configuration setting you need to worry about is when you're using a server as a witness server that is not also an Exchange 2010 server. Okay, if it's an Exchange 2010 server, all Exchange 2010 servers have full permissions to do stuff on each other, and that's not a problem. If it's not an Exchange 2010 server, then you have to add the Exchange Trusted Subsystem Universal Security Group to the local administrators group on your witness server. Okay, that gives the Exchange system the permissions to create and remove the witness share and directory as needed. Okay, if it doesn't have permissions to do that, and it needs to create or remove that witness directory, it's going to fail with an error. And it's going to warn you when you try to do DAG operations like add or remove members or run set DAG to check configuration settings. Okay, it's got to have the proper permissions to do that. Now, it cannot be a member of the DAG. The witness server is always external to the DAG. Okay, which means if you have a server you've already designated as a witness server, you won't be able to add that to the DAG. Similarly, when you pick a witness server, you won't be able to use any of the servers that are in your DAG as well. Now, it does have to be in the same AD forest. Can't be in a different forest, but there's no domain requirements for the witness server. It can be in any domain that you want, just has to be in the same forest. In terms of the operating system, Windows 2003 or later works fine. The only caveat is if you want to cluster the witness server and the share itself. Okay? For clustering the share, we're doing some unique things in Windows 2008 that require Windows 2008 on the cluster. If you're not clustering the share, then you don't have to worry about it. It can be any Windows 2003 box you want. I will also say there's really no need to cluster the share or the witness server. We don't need high availability for the witness server because, as you saw, it only comes into play where decisions of quorum are needed. Okay? Otherwise, it can go up and down, be used little or a lot. It doesn't matter. It's a very lightly used share, and you don't have to protect it using anything like clustering or high availability. Now, we don't support DFS for it, so it can't be on a DFS share. And you can use the same single witness server for multiple DAGs. So if you're deploying multiple DAGs, you can use the same single witness server. You do have to have your own unique share and your own unique directory for each DAG on that server, but a single server can be the witness for multiple DAGs. Okay, let's talk about DAG networks, because they're new. Okay, we didn't have them before we had DAGs. So what is a DAG network? A DAG network is nothing more than a collection of subnets. Okay? You've got a server, it's got one or more network cards in it. Each one of those network cards is on a subnet, and each of those collections of subnets represents a DAG network. Now, every single DAG will always and only have one MAPI network. This is the network that DAG server uses to communicate through MAPI RPC with other Exchange servers like Client Access or Hub Transport. Okay? And this is the network through which all client activities coming from CAS into Mailbox as well. Now, they can also have 0 or more replication networks. And we say 0 or more because we don't require a second network in DAGs. Okay? CCR, we require 2 networks, a public and a private. In DAGs, we only require 1, and that's going to be your MAPI network. And even though we call it the MAPI network, we'll use that for replication as well. If you add additional network cards, you're doing so because you want to add dedicated replication networks. And when you do so, those are the networks we'll use for replication unless they have a problem. If we have a problem on a replication network, we'll revert to using the mapping network to keep log shipping going. Okay, it's pretty simple stuff. Now, each of these networks, whether it's a MAPI or multiple replication networks, they're all going to be on different subnets. Okay, that's still a requirement for Windows, it's still a requirement for clustering, so it's still a requirement for Exchange. Okay, so if you have a MAPI card and you want to add a replication network, you're going to be adding a second subnet to that card, or to that server rather. Now, let's say you have multiple replication networks, which you can do. You can put as many network cards as your server will support, but each additional network you add is going to be for replication only. It won't be for mapping networks. We have an algorithm in there that determines which network it's going to use when you have multiple replication networks. And it's based on the least recently used principle. It's an LRU algorithm. We use it all over Windows and other Microsoft software. And basically it says, if I have a replication network that hasn't been used in a while and I need to replicate something, start using that network. And so it's kind of a form of load balancing, but it's not guaranteed load balancing. There's no guarantee as to which network is going to be used. You might think of it as almost a random selection, but there is a rudimentary algorithm there going and picking them so that we don't overload individual networks. Okay, so we've got your mapping networks and your replication networks. Those are the two kinds of networks. How do they turn into DAG networks? Well, they turn into DAG networks because, again, underneath the DAG is a cluster. And when we install Exchange into the cluster enumerates the network interfaces for us. Okay? And it tells us which network interfaces are on which subnet, and it takes the interfaces and subnets and translates them up into the DAG where they become DAG networks. Okay? So each individual subnet on each server is going to be a separate DAG network. So here's what it might look like. Here I've got two servers in my DAG, EX1 and EX2. And each of those two servers has two NICs in it, one for the mapping network and one for the replication network. Now, there's a couple key things to keep in mind. First, the mapping network, that's my 192 network right here. The replication network is my 10 dot network. Only the mapping network will have a default gateway. None of your replication networks will have default gateways for a couple of reasons. First, they don't need them. Even in a multi-subnet routed environment, they don't need default gateways. You can use route control, NetSH, to route traffic coming from the replication network to go over the interface of the mapping network. Okay, so that's not a problem. That's how you want to deal with it. Now, as you can see, even though I've got 1, 2, 3, 4 different networks, I've only got two subnets. The mapping network on both of the servers is the same subnet, the 192.168.0, and the replication number is the same subnet for both servers as well, the 10.0.0 subnet. Okay, so these are the network cards inside the server. When cluster enumerates this and we convert them into DAG networks, again, we take the subnets, and for every unique subnet we have, that's a separate DAG network. So here we have both of these are the same subnet, so that's one unique subnet. Both of these are the same subnet, so that's our second unique subnet. Because we have two unique subnets, we have two DAG networks. One for the 192 subnet, one for the 10 dot subnet. And in that subnet are our interfaces, the actual IP addresses that we gave to each of the servers. So when you have two cards in boxes like this, and they're relatively simply configured because they're on the same subnet, it makes things real easy, and there's no additional configuration that you have to do to get your DAG networks working. But now let's say we've got these same two servers, and instead of being on the same subnet, they're on multiple subnets instead. Okay, so now I've got the mapping network on server 1 on 192.168.0, and I've got the mapping network on server 2 on 192.168.1 instead of 0. Okay? Two separate subnets right there. Same thing with the replication. For server 1, it's on 10.0.0, and for server 2, it's on 10.0.1. Okay? So now I have 4 subnets instead of 2. So how many DAG networks is that going to enumerate for me? Shout it out if you know it. Yes, awesome, 4. That's right, 1 for each unique subnet. We've got 4 subnets here. Now, I've got a problem here. I've got 4 different DAG networks, but they each only have one interface associated with them. A network is 2 endpoints. It's not just enough to have one. If you only have one endpoint, you're not networked with anything. Okay, so you need 2 endpoints. So what that means is we need 2 of these interfaces to be collapsed up into the networks we want to keep. And it could be any 2 of these 4 that you keep, because ultimately data from 2 of them are going to move to the other 2, and then they'll be empty, and you'll remove them. So here's what that's going to look like. So again, we've got a same table here. Nothing's changed just yet. There's 4 commands that you're going to run. Okay, and I've color-coded them white, yellow, because some of them wrap around. They're each one-liners, but they wrap around, so you know where the commands start and stop based on the color. So this is 1 command, this is a 2nd, this is the 3rd, and that's the 4th. Okay, let's walk through what they do. The first command looks at DAG network 01. That's the identity we pass. And we're assigning these subnets to DAG network 01, the 192.168.0 and 192.168.1 subnets. And then we're also saying that replication enabled is false. So we're saying this is our mapping network. Okay? These are the 2 subnets that we want for our mapping network, and we're turning off replication. Then, for the replication network, we've decided to use DAG network 02. So we take both of those subnets, and we set that using set DAG network, and we put both of those subnets into that network. Then, because we've taken the subnets out of networks 3 and 4, they're empty now. So we just use remove DAG network to empty them out, and once they're both gone and you've done all that work, it collapses everything very nicely for you into 2 networks, each with multiple subnets and the appropriate interfaces. Okay? Now, because you've got the 2 endpoints in your replication and in your mapping networks, now we've got connectivity and things will work. Okay, what happens if you don't do that? Will the system still work? It will, but it will only replicate across your mapping network. Okay? And the very fact that you put replication networks in there says you don't want replication to occur over your mapping network unless necessary. So until you collapse the networks and make the endpoints all nice and neat and wrapped up like this, it's just going to use the mapping network and not use any of those extra network cards you put in there. Okay? So it's very important that you collapse these networks or they're not going to operate as you expect. Okay? Once they're collapsed, everything will be great. You'll have all the right endpoints. But until they're collapsed, it's not going to work the way you'd expect. Okay, some other things that you need to consider about DAG networks. I talked about the enumeration that we do. Well, that enumeration actually only takes place when you first add the server to the DAG. Okay, so let's say you've added the server to the DAG, and now you've decided to add in some extra network cards for a replication. Well, you have to go and manually tell the system to discover those new networks. Okay, and you'll use the set DAG commandlet with the discover networks parameter, and it will go and tell the cluster APIs to reinterrogate the system, find any new networks, and if appropriate, either add them to existing DAG networks or create a new DAG networks with the new subnets that you've added. Now, we do persist some of the DAG network configuration in the cluster registry. So, of course, for some changes that you're going to be making to the network, you do have to have quorum. If you don't have quorum in the cluster, you won't be able to reconfigure the networks because we need quorum to write to the cluster database. Now, unlike previous versions of Exchange and our high availability stack, we just had basic networking. So if you wanted compression, for example, you had to go buy a third-party WAN accelerator. If you wanted encryption, you had to configure IPsec or use some other type of technology to encrypt that traffic. Well, now at the DAG network, or at the DAG level itself, we support both built-in encryption and both built-in and compression. Okay, so what does that mean? You can yeah, I know what I almost said there. Thank you. It's compression and encryption, not to be confused with anything else that might sound similar. Okay, so we actually can offer it now because it's built in. So we use like the Kerberos security provider for the encryption. We use an internal algorithm called Microsoft Express, which is our proprietary implementation of the LZ77 compression algorithm, which is very common throughout the industry. But these are on the DAG level. So when you set these, you're telling the DAG to either use these features or not use them, or only use them when you're going cross-subnet. So maybe in the same subnet, you don't want to compress things, but when you're going cross-subnet across the WAN, you do want to compress things. And in fact, that's the default, is the inner subnet only for compression and encryption. Another big change that we made is in 2007, we were using server message block for our log shipping. for our continuous replication stack. And that worked really well, in part because of the scalability limitations of the system. We only let you have a maximum of 50 storage groups, or roughly 50 databases on the server. Now with 2010, we allow you to go to 100 databases per server with the Enterprise Edition. So we needed something that scaled a bit greater than SMB. SMB does scale, but only up to a certain point. The other drawback with SMB is that all of the individual replication sessions were all happening in the one larger SMB session. Okay, so that limited what we can do. So we did away with SMB, and now we're doing TCP-based log shipping. Okay, it's our channel that we open up. It's a single socket that we use. And again, you can do encryption and compression over that. But because it's TCP-based, it's very, very firewall friendly. Okay, we just need one port open to that box. The default's 64327. We set that up automatically for you. We put the exception in the Windows firewall for you as well. Even if you're not using the Windows firewall, we put that there just in case you turn it on. So the only thing you have to worry about is, let's say you decide to change that port. Okay, well, you can do that. You can use the set DAG with the replication port parameter and change the port. But you will have to go and make any firewall changes manually at that point. We'll only update the firewall exception during setup. So if you change the port later on, you have to go back and change your firewall rules accordingly to let that in. If you don't change the port, you don't have to worry about it at all. We'll just use that for the log shipping and get your logs going for you. Okay, let's go deeper now. Okay, as if that wasn't deep enough, let's go super deep now. Okay, so we're walking into the middle of the lake. Okay, the water's only about here right now. Okay, so we're going to talk about some more advanced features. We're going to talk about Active Manager. We'll talk about this process we have called best copy selection, and then we'll talk about DAC mode. Okay, I shorten the name, DAC mode now. Okay, let's talk about Active Manager. Active Manager is the brain of high availability. It's the resource manager that we built inside of Exchange to replace the resource management functionality we previously got from the cluster. Okay? We consume Windows failover clustering technologies now. We are no longer a clustered application. The cluster has no idea that we're there. We know it's there because we're using its Heartbeat APIs, we're using its node management APIs, we're writing to the cluster database. The cluster has no idea we're there. If you open the failover cluster management tool on an Exchange mailbox server that's a member of a DAG, there's nothing in services in applications. There's no cluster resources for Exchange. The cluster has no idea that we're there. Because it has no idea that we're there, it can't monitor us or manage us. And more appropriately, it cannot take corrective action when a failure occurs. Okay, in 2007, if a failure occurs, a disk blows up, the server blows up, it's the cluster service that reacts to that and takes the corrective action by moving those cluster resources over to a surviving node. We don't have resources that move around, so we have to have another mechanism that monitors things and takes this action. That mechanism is Active Manager. Now, Active Manager is the component that manages what we call starovers. Okay, starovers is short for switchovers or failovers. Okay, failover is when the system automatically does something. Switchover is when the administrator manually does it. Now, Active Manager is on every server in the DAG, and it actually runs in the Microsoft Exchange replication service. So there's no Active Manager service to find, and there's no Active Manager process to find. It's all under the Exchange replication service. Now, it's responsible for monitoring things, but when things go wrong, its primary responsibility is selecting the best copy to activate in response to a failure. Okay? Which passive copy is the best, and how quickly can I get it activated? It's also now the definitive source of where an active database is located and mounted. Okay? Historically, you got this information from Active Directory. But we can't store that information in Active Directory anymore. We have starovers that can occur in 30 seconds or less. I can't write that information to Active Directory because AD replication latency means it could take 15, 20 minutes or more before that data is sent around to all my other DAG members. So what we do is data that needs to change quickly like that, we have Active Manager writing it into the cluster database. Because the cluster database, all writes to that database are immediately replicated to all other cluster and DAG members. Okay? So now, It's not Active Directory that you would query through an application or through some interface to find out where the active copy of a database is. It's Active Manager that has that information. And in fact, there's Active Manager clients that run inside the CAS role and inside the hub role. And Active Manager in the DAG tells those roles where to find the active database. Okay, let's dig a little deeper here. There's 3 Active Manager roles. One of them, it's not so interesting, we don't care about it. That's the standalone Active Manager role. That's the role you get on a mailbox server before you put it into a DAG. Once you put it into a DAG, that mailbox server will inherit either the PAM role, the primary access Active Manager role, or the SAM role, the standby or the secondary Active Manager. Now, it doesn't matter which role it is. You know, it's still Active Manager. It's just doing different things based on its role. And as I said earlier, there's that Active Manager client that also lives on CAS and Hub so that the DAG can tell it where the database is located. So the PAM, that's the controlling Active Manager. The PAM is the one that is responsible for the best copy selection. It's the one responsible for reacting to failovers and things like that. It also gets topology change notifications, and it gets information from the cluster about when a server has gone down as well. Clusters are great for telling us when servers and networks go away, but that's about all they can tell us in this new paradigm. Now, it also is responsible for looking at the databases on that local server. So on the server it's running, it looks at the databases and verifies that they're healthy, and if they're not healthy, it also reacts to that condition by failing over to a healthy copy. Now the SAM, the Standby Active Manager, that's on every other node of the DAG. The PAM is always going to be whatever node owns the default cluster group. Okay, that's always going to be the PAM. Why? Because there's only one node that can own that group, and we only want one node to hold that role. And it's very easy to make that association. So wherever that group goes, that's who's going to inherit the PAM role. Every other member of the DAG that doesn't own the cluster resource gets the SAM role automatically. Okay, and if you move the cluster group around, they'll change roles. SAM will become PAM, the previous PAM will become SAM, and so forth. Now, the Standby Active Manager, that is not responsible for reacting to any failovers. Instead, it notifies the primary Active Manager when a problem occurs and has the PAM react to that sort of thing. So the SAM is more sitting there waiting to take over for the PAM and also answering those queries from CAS and Hub as to where a database is located. Okay, let's talk about best copy selection. Okay, this is important because it's literally the core function of the high availability platform. Best copy selection, or BCS as we call it, is the process through which the next best passive copy is activated by the system. Okay, so you might have 6 copies of a given database. Okay, but when the active copy fails, only one of those remaining copies is going to be active. And the system has to decide what's going to be the best copy to activate. They might all have different criteria at that point. One might be further behind in log shipping. One might be further behind in log replay. One might have an unhealthy content index catalog. One might have an unhealthy database status. Or perhaps the server or the databases have been blocked for activation by an administrator. So there's a lot going on in the system, and there's a lot that goes into the BCS process. And the BCS process has actually changed a little in SP1. So let me first talk about what we do in RTM. The difference isn't too big, but it's big enough where there is a behavior change here. So in RTM, a failure occurs. Okay, so the first thing that Active Manager does is it looks at all of the available copies that it can activate. Okay, and it sorts those available copies by their copy queue length, by how many log files have not been copied over to that passive copy. Okay, the lower the copy queue length, the less data that's missing, so the higher we go in the list. Obviously, you want to activate something that's missing a little data before you try to activate something that's missing a lot of data. Once we have that list, if we find that any 2 copies have the same copy queue length, for instance, copies 4 and 5 are both 6 logs behind, then we have a secondary sorting key called activation preference. Activation preference is a numeric value associated with each database copy that the administrator sets. So your original database, it's going to have an activation preference of 1. The next copy you make will get 2, the next one will get 3, and so forth. And then after they've been assigned that number, you can change them around. You can make the second copy 1, you can make the third copy 4, etc. But either way, they'll all have that number so that no two will be identical. So even if we have a tie on copy queue length, we'll always be able to do a secondary sort on activation preference because it will be a unique number. Then, once we have our sorted list, we will pick from that sorted list based on a set of 10 criteria. And I'll show you what the criteria are in a minute. But there's 10 things that we look for, and as soon as we find a database on that list that meets the first set of criteria we pass into it, that's the copy that we try to activate. Okay. In trying to activate, we run a process called ACL, Attempt Copy Last Logs. And what that does is it goes to the original source, the original active, the one that just failed, and it tries to copy any missing log files over to the passive copy it's trying to activate. Okay? Now, it may be successful, it might not be successful. We don't know at this point, but the behavior is the same. It's still going to try. Perhaps the reason the database failed is because the server's rebooting, and when it goes to try to copy it from that server, it can't copy anything because the server hasn't booted back up yet. Okay. In SP1, almost everything is the same. The one difference is in this dial setting that we allow administrators control. Okay? The dial setting is called the Automatic Database Mount Dial. Okay? It's not new to 2010. We introduced that in 2007. It's an administrator control. It's a dial that they set that says, I'm willing to lose X number of log files and still have my database be mountable. Okay? Which is revolutionary when you think about it. In 2003, if you were missing even one log file, you could not mount that database. Okay, now we have a dial setting that we introduced in 2007, carried forward to 2010 and changed some of the values that says if I lose X logs, it's okay to still mount that database with that data loss. So we've got a setting like best availability. Okay, so that would be 6 logs lost, or excuse me, 12 logs lost. We've got good availability as well. And we've got a setting called lossless. Lossless is the setting that says 0 logs lost. If there are any logs missing, including the current log file, do not mount that database. Now, how does that play into the behavior change? Well, the behavior change only manifests itself when you have that dial set to lossless. If you don't have the dial set to lossless, if it's set to best availability or good availability, the process for BCS I just walked you through for RTM is the same in SP1. But in SP1, if you have that dial set to lossless, then the change is, instead of sorting the copies by their copy queue length, we sort them first by that activation preference. In other words, we're using activation preference the way I think most people would expect us to. In RTM, we use it as a tiebreaker. In SP1, we use it with real relevance. We use it as the weighted decision, as if an administrator had broken the tie for us, because that is in fact what the activation preference value is intended to do. It's to break that tie. Okay, but now it's a way, when you set it to lossless, for the administrator to say, I want to make sure that things are set to lossless, and I want things to be sorted by activation preference so that databases I prefer to become active have a greater chance of becoming active than other databases. Okay, the process is the same, though. It'll select based on the criteria. You'll see the criteria in a minute. ACL runs, again, only going back to the original source to get data. Now at this point, we're back to where we left off with RTM. We're at the same point in time. So ACL's done its thing. Doesn't matter if it's RTM or SP1. It tried to copy logs. And now the question is the database mountable? Okay? The answer to that question is this. Is the number of missing log files greater or less than the value of the auto database mount dial setting? Okay? If it's less than the setting, say for instance, you set it to best availability, so you can lose 12 logs, but you've only lost 4 logs, yes, it's within the dial range and the database will mount. If it's outside the dial range, maybe you set it to lossless and you've lost a couple logs, then we will not activate that database. Okay? Instead, we'll go to the next one in that list and we'll try to activate that one instead. And what's interesting because of the nature of failures and due to the timing of things and rebooting and whatnot, it could be that the next best copy activates without any data loss because perhaps now the original server has been rebooted and you can copy all the log files from that server now. Okay, so it could be a timing thing in there. So I mentioned the criteria. These are the 10 sets of criteria that we look at. And as you can see, as we go through these, we sort of degrade the criteria a little bit, sort of loosening up and making sure that we can find a copy to activate. Everything doesn't have to be in a perfect world. So we do start out with a perfect world, a copy queue length of less than 10 logs. In other words, 10 logs or fewer have yet to be copied over. A replay queue length of less than 50 logs. We want a low replay queue length because to activate a database, we have to replay all outstanding log files. So the lower the replay queue, the faster we can activate. And then ideally, after we've activated, we want the client search experience to be good. So the best of all worlds tells us the content index status is also healthy. Now, if we can't find a database on your list that meets that criteria, we degrade it a little bit. In this case, going from a healthy index to one that's crawling. Crawling is indexing. Okay, so search isn't up to date, but at least it's there and it's working on it, and that's a good experience to move towards. Not as good as a healthy catalog, but better than a failed catalog. Then we'll start to play with the criteria a little bit. For a while, we'll drop off the copy queue length and only look at replay queue length and content index status. Then for a while, we'll go back and look at copy queue length and drop replay queue length off and then mess with the content index status. And then finally, we'll just say any copy with any one of these 4 statuses. If we can find a copy on your list of this database that has any one of these 4 statuses, we'll try to activate that. Now, it might not be the best experience, but at least it's trying to activate until it runs out of all possibilities. And that, I think, is what you want out of the system. You want it to keep trying as best as it can. At this point, if it can activate, well, then at that point, it's time for user or administrative intervention to figure out what's going on in the system. Maybe you've run out of copies. Maybe some copies were blocked and you didn't realize it. But the point is, it's going to try very, very hard to activate a database. So let me give you some examples of how it might work between RTM and SP1. And these are very simple examples. Just 4 servers in my DAG, 4 copies of DB1. DB1's currently active on server 1, but as things happen, server 1 has some sort of a failure that affects DB1. Now down here, we can see a snapshot of the state of things. I can see that DB1 has an activation preference of 2 on server 2, 3 on server 3, 4 on server 4. These just happen to match numbers. Again, the activation preference could be any number based on the number of copies that you have. Here, we've got pretty low copy queue lengths, no greater than 10 for server 4, but the lowest is clearly server 3. Replay queue length is pretty low on all of them. Got a healthy index crawling over here on server 4. And the database state is activatable for all of these states. Healthy, obviously. The other one is disconnected and healthy. That means we're not in communication with that server anymore, but the last time we talked to it, it was healthy. So we call it disconnected and healthy. So later on when we reconnect, maybe it'll come back healthy. We don't know. Okay, so I had a failure occur, and the first thing we do is RTM. Again, we sort them by copy queue length. Okay, that's that column right here. So we've got 4, 2, and 10. The one with the lowest copy queue length is server 3. The next lowest is server 2, and the highest copy queue length is server 4. So 3, 2, 4 is our sort with Again, if any of these copy queue lengths were the same, that's when we would use activation preference as a tiebreaker to resort this list, with the database having the lower activation preference being at higher on the list. Okay, so what does that mean? We're trying by copy queue length here first. Okay, now out of all the copies that we have, we've got 3 copies. Only 2 of the copies meet that first set of criteria. Going back to that table of criteria. Okay, only 2 of the copies have a copy queue length less than 10, and a replay queue length less than 50, and a content index status of healthy. Okay, and out of those 2 copies between server 3 and server 2, server 3 has the lowest copy queue length, so it will be tried first. Okay, that's the server we'll try. That's the database copy we'll try to activate first. And again, remember the activation process is going back to server 1, which is down now, and trying to get missing log files. If that's not possible and the dial is set to lost list, the database 1 on server 3 won't activate. It'll try server 2 next and then try server 4 next until it has all of the missing log files. Okay, now SP1. Same scenario, the only difference is we've set the auto database mount dial to lossless. Otherwise, everything is the same copy queue length, same servers, same failure scenario. Okay, so database fails. Now we have our sorted list, but we have our dial set to lossless. So we don't sort the list by copy queue length anymore. We sort it by activation preference. So 2, 3, 4 happens to match our activation preference. And because server 2 has the lowest preference value, it now will be tried first. Okay? All right. Now, remember, it's Active Manager that determines the best copy to activate. And after ACL runs, that determines whether or not the database is going to be mountable. Okay? If you're within the dial setting, we'll mount the database. If you're not, if you're outside the dial setting, we've got to go try the next copy. Okay? But let's assume we're within the dial setting and things worked and we've activated the copy. Okay, so what happens after that? Now the copy's been mounted. Well, that's not where the system stops. Okay, because the mounted database is going to be generating new log files, but based on your dial setting, it might be missing some data from old files, or from the other log files that it might be missing. Okay, so that's where the transport dumpster feature comes in. Okay, after we had this failover scenario where we lose data, we actually have a name for that. We call it a lossy failover. Okay, we call it lossy because there's data loss involved. Okay? Now, unless you have things set to lossless and you're forcing mounts after you've got all the data, just about every failover you're going to have is going to be a lossy failover. And the data that would normally be lost through maybe a bad disk or a server being down so you can't copy the log files is going to be recovered by the transport dumpster. Okay? That data is sitting in there, and inside the transport dumpster is only data that has not been replicated through the pipeline yet. Okay, so it's that data that's going to be recoverable and sent back to that mailbox server. So you had a lossy failover, but you're not necessarily losing data as a result of that. We're getting those messages back from the transport dumpster. Now, let's say you repaired server 1, fixed whatever the problem was, and got that database up and running. Okay, at that point, the database is going to go through what we call divergence checking. And if it looks like it's not very diverged from the new active copy, it'll actually bring itself back up to date. In some cases, even throwing out data that it has in favor of new data coming from the new active copy. But if it turns out that the nature of the failure was such that the disk is just destroyed and the database is gone, then of course you'll have to do a full reseed to get that passive copy and get your redundancy back up and running. But you may or may not have to reseed. It really depends on the nature of the failure. Okay. Let's talk about DAC mode, Data Center Activation Coordination Mode, DAC mode for short. Okay, so what is DAC mode? Well, it's a property of a DAG. Okay, it's a setting, it's an attribute of a DAG. And we put DAC mode in there to act as an application level of quorum to account for the scenario in which you have a power failure in the primary data center, and then power is restored, but you don't have WAN connectivity restored after power comes back up. Okay? What you don't want to have happen is power coming up again, and in the absence of WAN connectivity, one side mounting databases that are already mounted on the other side. Okay, that is what we call split brain. Okay, and split brain is a phenomenon that's not unique to Exchange. It's a phenomenon that can happen in clusters when all nodes lose communication with one another. Okay, they may mistakenly believe that they are now authoritative for that cluster or for that DAG, and they'll try to bring things up online. Okay, so we have DAC mode in there. In DAC mode, in the RTM, it's only for DAGs with 3 or more members that are extended to 2 AD sites. In SP1, everybody's invited to the DAC mode party. Every DAG can be in DAC mode in SP1. Okay? Now, DAC mode, yes, it's an application level of quorum, but the other advantage that you get is you get the benefit of using our site resilience tasks. Stop DAG, restore DAG, and start DAG specifically. Without DAC mode, if you do a DAG in the site resilience configuration and it's not in DAC mode, you have to use the cluster tools in order to do the data center switchover. But if you're in DAC mode, you use only Exchange tools, and we make it much, much easier for you to do it. And again, DAC mode is now enabled for all DAGs in SP1. So how does it work? Well, DAC mode is based on a bit. It's based on the Data Center Activation Coordination Protocol, or DACP. You like that name? I came up with it. Pretty long, I know, but I thought it sounded cool, so we went with it. But it's really nothing more than a bit in memory. Okay? It's either a 0 or a 1. A 0, I can't mount the databases. 1, I can mount the databases. Okay, so how does it work? Well, on startup, obviously everything in memory is gone. So when we start up, the normal state is to have a DAC-P bit of 0. Okay, you're not allowed to mount databases unless and until you can either talk to all other DAG members, or you can talk to one DAG member that has its DAC-P bit set to 1. If you can talk to another DAG member that has its bit set to 1, it has permission to mount databases. Therefore, you'll have permission to mount databases based on communication with it. So think about the scenario this was intended for. Okay, we've got 2 data centers. We'll just say these are our 2 data centers. Okay, and power goes down in one of them, and then it comes back up, but there's no network between them. Okay, power goes out, which means these are all being rebooted. Okay, so their DAC-P bit is set to 0. Because there's a break in the WAN connectivity, they can't communicate with anybody with a DAC-P set to 1. Okay, so they won't mount their databases. If they could communicate, then the WAN's up and running. They'll get a 1 from any of the other DAG members, and they'll be able to mount. But they can't communicate, so they won't mount, and that's how we prevent databases from mounting in both places. Okay, using DAC mode and the DAC-P bit. It's pretty simple stuff, but we gave it a fancy name to make it sound cooler than it is. Yeah, it's pretty cool. Okay. All right, so that's the deep dive stuff. The last thing I want to talk about, and I know we've just got a few minutes left, and so I'm going to try to go quickly through them because I know there's another speaker coming. I just want to talk briefly about some of the improvements that we've done in the HA space and the site resilience space in SP1. So the big one, normally I'd save the biggest for last, but I think I want to give the biggest first because it's just that cool. So we've actually introduced a second form of continuous replication in Service Pack 1. And that's an interesting thing to do because we had the original form, and now we had to come up with a new name for it to distinguish it from the new form we've introduced. Okay? So the new form is called continuous replication block mode. And so that means the old form we're now calling continuous replication file mode. Okay? You can probably guess where I'm going with this. In the old form, we're shipping log files. Okay? In the new form, we're shipping log buffers instead. Okay? So we're not waiting for a log file to fill up. We're shipping that data as soon as it's written to the buffer. Now, it's an asynchronous write, so we're not waiting for a commit on the other end, but we're shipping it off as soon as possible. It's a more granular form of replication that gets data off the box faster, and in doing so, further minimizes the potential for data loss. Here's how it works. Here's some fancy, fancy animation for you. Okay? Now, the initial mode is always going to be file mode. And you may know that I mentioned some of how we changed things in terms of continuous replication. But one of the other changes that we made that I didn't mention yet is that we've moved from a pull process to a push process. Okay, in 2007, to do replication, the passive copy reaches out into a read-only share on the active copy, grabs a copy of the log file it needs, copies it over to itself, inspects it, and replays it. We don't do that anymore. Now, the passive copy tells the active copy through our encrypted TCP channel what log files it has. So in this case, send me your latest log files. I've got up to log generation 2 over there. And of course, the active says, well, I'm up to generation 4, so I'm going to start sending you 3 and 4, and they're going to go over it, and you're going to have them, and you're going to inspect them, and then replay them as appropriate. And meanwhile, I'm still doing my thing, and I'm generating other log files while I'm doing the shipping over to there. So life is continuing as you might expect. But now we're at the point where the passive copy is up to the date. The next log file it needs is the current log file that's in use. There are no more closed transaction log files that haven't been shipped to the other side. So now it says, hey, I'm up to date. Let's switch into block mode. Okay? And it switches into block mode, and that spins up a replication log buffer on the passive copy side. We already had the ESE log buffer on the store side because that's there for the store activity. Now we've got a replication buffer that we've spun up on the passive side, and every time we write a block of information on the active side, we asynchronously write that same information into the log buffer on the passive side. So we get another chunk of data. We write that in both places. We get another chunk of data that fills up the log file. We write that in both places. And then independently, both places construct and inspect a log file. Okay, so a lot of people ask, okay, well that's great. Well, what happens if I'm replicating a partial set of data, and then before we fill up that log file over there, the active copy dies? Okay, we've actually thought about that too. What we do is we call that a log fragment, and we take that log fragment and we convert it to a full log file. And that's nothing new or unique. We've been doing things like log roll in Exchange 2007 for a while. So filling up a partially filled log file is not magical or earth-shattering. But the point is, we have that little bit of data. And we can take that data and turn it into a log file that can be replayed into that passive copy of the database. Okay? So in doing so, we minimize the amount of data you could lose when we switch in and out of these modes. Now, there's no configuration. There's no knobs, there's no checkboxes, there's nothing you can do to manage this at all. It's just going to turn itself on and off automatically as copies are able to keep up. Okay? And it'll do so independently. So if you've got 3 copies of a single database and 2 of those copies are able to keep up but one's not, 2 out of the 3 are going to be in block mode and the third one's going to stay in file mode until it can catch up. If it is in block mode and it starts to fall behind, it will automatically revert itself back to file mode. And when it catches up, it'll automatically go back into block mode as well. Okay? So you don't have to worry about it. You don't have to manage it. There is a performance counter that will have a 0 or a 1, so you'll know which databases are in it. But largely, you don't have to worry about it. The system will just do its thing automatically. Some of the other improvements that we've done, we've got a lot of new scripts in there. One of the scripts is called redistribute active databases. Okay? It's important when you're doing your database layout and your DAG design that you're evenly distributing your database copies across the DAG. And one of the things that we found in the service, in our Exchange Online service, where we've got about 40 million mailboxes right now, is we're used to doing these things called target list switchovers. Okay, so I can walk up to a server. I need to do maintenance on this server. Before I do maintenance on it, I need to do a switchover. I need to take the active databases off of it and move them onto some other servers. Okay? Now, when I do that switchover, I have a choice. I can make it target list. In other words, I can let the system choose what servers to activate on. Or I can say, activate these copies on this specific server. Okay? In the service, we like to choose target list, let the system pick it out, and it'll just find the best copy to activate at that point. But what we found out, though, is that that led us to uneven distribution of our databases. Uneven in terms of activation preference, uneven in terms of where the copies were located, where we wanted them to be located, and so forth. So we came up with a very sophisticated script called redistribute active databases. And what it will do is it will spread that load evenly across your DAG. Okay, so look at things like activation preference, make sure that that's balanced out. It'll look at copy location, make sure that's balanced out. And you actually can do that not just by activation preference, but you can also balance them out across sites as well. Okay, so you can balance within a site or across sites as well. And you'll probably want to do this several times. Throughout the life cycle of the DAG, you should expect databases to move around quite a bit. And every once in a while, you're going to want to run this script to redistribute them. How do you know when to run the script? Well, when you run the script, it will tell you how things are distributed now. So you'll know if things need to be redistributed or not. We've got really good examples in the documentation of what an uneven or unbalanced DAG looks like, if you will, and what a balanced DAG looks like. And so you'll understand how we're rebalancing within inside the DAG when we do this. Okay, some other things that we've done, we've got some failover improvements. We've got faster failover. So in RTM, when there was a failure affecting the active copy, and we picked that passive copy that we wanted to activate, we would immediately stop replay on that passive copy. Okay? Even though there may have been work that we're doing and that copy could have played a few more logs, we stopped it cold. And we did a bunch of stuff to activate it, then we made it the active copy, we sent over the missing log files, and then effectively it was in a dirty shutdown state because we stopped replay, and now it had to replay all of those outstanding log files. Okay, now what we do is we actually allow replay to continue on that passive copy until the last possible minute. So generally, there's only about 1 or 2 log files that should be outstanding for that passive copy. It's almost effectively in a clean shutdown state. It's not, but almost. It's very close. And that means it's going to come up much faster because it's only got a couple log files it has to play. And that means failover times that used to take perhaps 20, 25 seconds are now only going to take about 10 or 15 seconds. So significant improvements in failover and switchover times. We also have included some maintenance scripts for you as well. Start DAG maintenance and stop DAG maintenance. We wanted to make it easy for administrators to take servers out of production and put them back into production without having to go through 30 different steps. So we have these scripts, for instance, start DAG server maintenance. It helps set the stage for maintenance. It'll suspend replication for the copies on that server. It will pause the node in the cluster. So that'll prevent it from participating in failover decisions. It'll prevent it from becoming the PAM role if it doesn't already have the PAM role. If it does have the PAM role, it'll move it to another node for you. It will also block the server from activation during the maintenance window as well, so you don't have to worry about that happening. And then, of course, when you're done with start DAG server maintenance and you've done the operations, then you run stop DAG server maintenance, and it undoes everything and puts it all back together for you. Okay? So that's what stop DAG server maintenance is. It'll do the resume the node, set the policy back to unrestricted so things can be activated and so forth. So that's another big plus. We help you maintain your DAGs in a very easy to use way. We also have two scripts that we introduced in RTM. One is collect over metrics for collecting failover and switchover metrics. The other is collect replication metrics, and that's there to collect the log shipping activity statistics as well. Now, if you've used these in 2010, be aware they've been rewritten in SP1. Okay, so if you've been used to using them, we've got new parameters, new reporting output, and new ways to do things. The scripts or automation you may have built around these in RTM won't work in SP1. You'll have to change it slightly. It's not a big difference, but it's a difference. You'll have some new parameters to deal with. But those scripts are still there, and one of the reasons we rewrote them, well, there were two reasons. One is the way they were written was a little bit too resource intensive, so they were taking a little bit too much time to return the results. But the other reason is now they're also a lot faster in terms of the results that they get. Okay, so you'll be able to get data a lot more quickly, particularly in larger DAGs that are 13 to 16 members. A couple other things that we've done. We're almost at the end here. We've added new Exchange Management Console GUI for the database availability group story. Okay? In RTM, we did not have a complete GUI story if you were using static IP addresses for your DAG. If you were using DHCP, we had a complete story. But if you were using static IPs, the only way to assign one or more static IPs to a DAG in RTM was to use the Exchange Management Shell. We didn't allow you to set it through the GUI because there was no interface. In SP1, we added interface for that. Okay, so you can go to the properties of the DAG. You can add multiple IP addresses in here if you've got a multi-subnet DAG, and that completes the GUI experience. You can now completely build and configure a DAG using the console. You don't have to use the shell for IP addresses. Also in RTM, you had to use the shell for setting the alternate witness server and alternate witness directory. These are secondary witness servers and directories that are used in site resilience scenarios. Okay, so after you've activated a secondary data center, you need to point the DAG towards an alternate witness server. You can do that ahead of time by pre-configuring that alternate witness server, or you can pass that into the restore DAG commandlet when you're actually doing the site activation. But either way, we now have that in the GUI as well, and you don't have to go to the shell to configure a simple configuration item. Okay. And with that, I know we are a little bit over, but I am very happy to take any questions that you might have. We might have to step off to the side in a little bit, but we will get to all your questions. And for those of you who don't have questions, I want to thank you very much for coming, and please remind you to fill out your surveys. And then if you do have questions, just go ahead and come on up here, and we'll get out of the other speaker's way, and we'll get all those answered for you. All right, so thanks very much for coming.